Hello everyone, we're doing a video examining some multiple choice exam questions on the ideas of resultant force and how force relates to acceleration of a mass and of the concept of momentum. Now before you work on these, please make sure that you have worked through the video tutorials from exercise 13A and 13B on the Google Sites and have practiced some of the exercise questions. Okay, so here's our first question. We looked at this one in class. Two forces P and Q act on a body P is in the direction of I for magnitude of 1 Newton, and Q acts in the direction of this other vector I plus root 3j for magnitude of 4 newtons. Okay, now we have to go ahead and find the magnitude of the total force acting on the body in newtons. Now the total force, that's the same as the resultant force, and your resultant force is the sum of all the forces acting on the body. Okay, so this is force P plus force Q. Alright, now what do we know about each? P is 1 Newton in the I direction, so that's the size multiplied by unit vector I. Now what is Q? We've told that Q has a size 4 newtons and is in the direction of another vector I plus root 3j. Now we have to use that information and draw on the idea that a vector is always made up of a size and its direction. Now the size is the magnitude of the vector, the direction is the unit vector itself. The unit vector of Q will be the same as the unit vector of the I plus root 3j. Okay, so direction is the same for Q and for this vector. So if we find this unit vector, it will be the same as the unit vector for Q. So we take the vector, divide by its modulus, we get a half. Okay, now therefore we're going to write what Q is. Q is its size multiplied by its unit vector. So we take 4 units multiplied by half times I plus root 3j. Okay, so we've got what P is, we've got what Q is. Let's come back to the resultant force. Okay, so we're adding the two vectors together, and we now collect our like components, and we've got 3i plus 2 root 3j. And the question asks the magnitude of the total force, so we're finding the magnitude of this resultant force vector we just worked out. We get 21, root 21, and that is option D. Okay, excellent. Let's keep going. So next question. A 5 kilogram mass has an initial velocity, 4 meters per second. The mass increases its speed by accelerating in a straight line at a constant rate of 2 meters per second squared. Now after traveling 21 meters, the magnitude of the momentum of the mass in kilogram meters per second is this value. So this last bit, that's just your units for momentum, mass times velocity. So we draw on that definition. Momentum is mass times velocity. Okay, please make sure that you've reviewed exercise 13B. Alright, now from the information, let's summarize. We've got a displacement of 21 meters. We've got an acceleration of 2 meters per second squared. We've got an initial velocity of 4 meters per second squared. Now, to work out momentum, we need final velocity. So a rule for final velocity that draws on constant rate of acceleration, okay, that uses a U, an X, and an A is this one. Okay, now let's work out final velocity. We substitute our values in. 16 plus 84 gives you 100, so V is 10 meters per second. Okay, then we take our value for V and we work out what momentum is. 50 kilogram meters per second. and it's option D. Alright, very good. Let's try the next one. Okay, so a constant force of 10 newtons acts on a mass of 5 kilograms initially moving at 1 meters per second. After the mass has moved a distance of 20 meters, the magnitude of momentum is equal to. Okay, so this is very similar to the last one. Let's have a think about it first. First off, we identify well, we've got force of 10 newtons. And we've got a mass of 5 kilograms, and we've got initially moving, so its initial velocity, a u of 1 meter per second. And x is our displacement, is the moved of a distance of 20 meters. And our job is to go ahead and find the momentum. Magnitude of momentum, that is. So just the size, and the size is given by this rule for the size of velocity. Alright. So, first off, our final velocity is worked out by this rule, like the previous question. So we can go ahead and calculate that. However, we realize we don't know what A is. And we're going to get A from F equals ma. Alright, Newton's second law. And so A must be F divided by m, force divided by its mass, which is 2 meters per second squared. Okay, now taking that value for A, we're going to put it into our final velocity rule. Work out our final velocity, and we get 9 meters per second. And from that, we can evaluate momentum. 45 kilograms per second. So it must be D. It's option D bonanza. Okay, next question. So, three forces, F1, F2, F3, act on a particle which cause the particle to move in a straight line with an acceleration. Okay, so if F1 is this vector, F2 is that vector, and F3 is this last vector, measured in newtons, then the mass of the particle is equal to. So, we've got to find mass from force, three forces acting on a particle, and we can draw on the idea of a resultant force of the three particles. Okay, so I'll give you a few minutes to think about it. So let's work it out. We've got a resultant force, F1 plus F2 plus F3, gives you a resultant force, and we add up our components. So we add the I components, we add the J components, and we add the K components, and we get this. And then we draw on Newton's second law that says, well, all the sum of the external forces add to give you mass times acceleration. So we need the size of that resultant force. Okay, and we take the modulus of the resultant force, we get square root of 30. So that means our resultant force there is root 30. Sum of forces is 30, and Newton's second law is mass times the acceleration of 2.5. Now 2.5 as a fraction is 5 on 2, and using that we can solve for m, and we get option B. Fantastic. How'd you go? I hope that was helpful. I'd like you to continue on. Let's look at the inclined plane, and exercise 13C. Well done.